to show you the difference between serial and parallel. And you have in and out. So when you have registers, you can load values and you can also get values out of it. And so parallel means that you're doing two at the same time, and serial means you're doing one after the other. And so if we look at A right here, we have step 1, we have one little block coming in. Step 2, we have another block coming in. Step 3, they're just moving along. Step 4, they're both being shoved out at once. So is this parallel in or serial in, and is it parallel out and serial out?
What does that mean?
Okay, so serial means you're doing one at a time. Parallel means you're doing them all at once. So it's serial in because I'm putting one in at a time, and it's parallel out because I'm pushing them both out at the same time. So in terms of a register, the way this would look with a register, when you've got a register, so we've got, say we've got our, it's a 3-bit register, and we're using D flip-flops. So a parallel load would be, let's say I had this set and it was supposed to be when S equals 0, I get a parallel load. I should draw these flip-flops in a better place. I mean, multiplexers. Whenever you have to design a register, your register is going to have D flip-flops and multiplexers. So however many bits your register has, that's how many D flip-flops you have, and every D flip-flop will have a multiplexer with it. And I was being lazy here, and I'm just giving it 2 choices. So you'll have some signal that's going to your multiplexer. These are 2-to-1 multiplexers, so it only has a choice of 0 and 1, but you often would have 4, so you'd have 0, 1, 2, 3, 4, or even 8. So if I had at S equals 0 that I wanted a parallel load, that would mean that I would have it's not supposed to be going, the signal goes into like the side or something. So A, B, C, so they all load at once. That's parallel. And if I had S equals 1, serial load from the left, and this we would call this a shift because we're going to be moving things along. So what that would do would be I'd have something, so I'd have n would be some variable here, and n would go into the multiplexer from the left, and then the output from D1 is going to go to that one, and the output from this one is going to go to that one. So what serial did is it moved it into one, and then this one went to that one, and that one went to that one. And if it was going to the right, it'd go the other way. But that was a load. I didn't do any output. That was just loaded. Okay. Now, going back to my picture. Okay, this B, what is that in terms of parallel in, parallel out, serial out?
Parallel out. Oh wait, parallel in, serial out.
Yeah, parallel in, serial out, because they're both coming in at once, but they're going out one at a time. And the last one?
Parallel in, or no, serial in, serial out.
Okay, so now let's look at okay, so here's an example of a register. And this register can either hold its value or load a new value in parallel. So if you look at what it's doing, is if R2, R1, R0, those are what in the one I just did a minute ago, I had A, B, and C. Those are the things that, well, okay, I want y'all to tell me, in this one, what your yellow is the signal that tells you whether or not you are loading in parallel or shifting right. So for what value of yellow, this is going to be the last thing that we do. For those of you who are yawning, I don't know why, it's terribly exciting. For what value of yellow
You're posting all this on Google, right?
yeah, do we get a parallel load? Okay, so for what value of yellow do we get a parallel load? So, do y'all read, can y'all read script? Like cursive? Okay, because I have like some younger people that I know that can't read it because they didn't ever learn it. Okay, so here's my question. So, yellow is a single variable, it's a single bit, so it can only be 1 or 0. And which one of those corresponds to a parallel load? One, because if we look at our multiplexer, any one of these multiplexers, we see that we are having the load going into the 1. So that means when yellow is 1, it's our output is going to be whatever it is that's coming into that 1 right there. Now, when yellow is 0, our output of the multiplexer is going to be whatever is coming into the 0, and what's coming into the 0 is just the value it had before. So it's just holding its value. Now this says, draw a similar register that can either hold its value or shift right with serial input in and serial output out. So we would have, anytime you need a register, you'll have flip-flops. So I'll have 3 flip-flops. And I will have 3 multiplexers, 1 for each flip-flop. And 0, 1, 0, 1, 0, 1, and I'll just have, I'll put S up here, well, I'll have S here. These are D, and I'll also have a clock. Well, I'll do that. The output from the multiplexer is always your input for your flip-flop when you're doing a register. Okay, so we wanted it to either hold its value or shift right. So to hold its value, the output is just going to be the input. So I'm making it hold its value when S is 0 because I'm putting it into 0. Now it says shift right. So if this is 0, 1, and 2, shift right means the output from this flip-flop becomes the input for the one to its right. And then it's shift and not rotate. So I'll have serial in is a variable, and serial in will come here, and serial out is going to be the output from the last one. And then real quick, how I would do this in Verilog. So when do I want this? So I have my inputs and outputs. I'm not going to put all of that up there. What do I want in my sensitivity list? When do I want this to happen? Actually, I want it at positive edge of the clock. So always at positive edge of clock. Then I have to have a begin here because I have more than one thing, and I'm gonna say that I defined up here. I have next state. I can never remember. So it'd be reg next reg. Oh, why don't I just do 3 values? That's right, 3 values. Okay, so then I'll have my begin, and then I'll have if S equals 0, then I would say, and what was 0? 0 was staying the same. Well, I don't really have to do anything here if I'm not using 2 always blocks. So I really don't have to do this one. I could just say if S, because if S means if S equals 1. So if S equals 1, then D0 becomes equal to serial in. D1 becomes equal to D0. Now see why it is very important that I use non-blocking here, because otherwise D1 would become serial in, and I need D1 to be what D0 was. D2 becomes D1, and serial out. So I'm making serial out. Serial out would need to be a reg 2. Serial out is D2. And I need to begin my if. So begin my if, end my always while.
So you said if S like that equals 1. Could you put S equals 1 if you want to?
Absolutely. Yep. And I don't really, I mean, people have different opinions. Some people say, oh, use it, make it as elegant as possible. It's just like, no, make it so you can read it, And so if S equals 1 makes more sense, then certainly do that.
Make it so the SI gives us points.
Well, I don't give points.
For
You mean the TA?
the TAs.
The TA, yeah. Yes.
On the regs, right after like D0,
Yes.
semicolon, it's supposed to be a comma or? Is it
Those are supposed to be commas. Yes, thank you. That would definitely give me an error, and it would take me forever to figure out what it was. Yep. And what I was trying to remember when I said, oh, I'll just do separate variables, is I can't ever remember where. So I could have done this as no, wait. I'm drawing a blank, so I can't remember what my syntax is for that. So I just.
So whenever we use the numbers inside of brackets, is there a reason that we put 0:2 instead of 2:0?
Yes. So
remember.
I will explain it then.
Okay.
So I need to make sure I get the syntax right. So hold on, let me get it.
Because we were in the line and the issue is that no idea.
No, it is important. And if I could get this out of the way. If you need to go, that's fine. I'm done. Okay, so the reason it's important depends, it is only important in certain instances. So it's important in that if I have,
So it's not that it's incorrect, it just means.
no, it's
something
just
else.
different ways of doing it. Oh, I'm trying to open a video here. So it's, if you're going to be referring to parts of it and you're doing it like, okay, so like right here, I have output 15:0 LED. And so what that means is that when I have, when I put in, if I wanted to put in, let's say I did D 4:0. So 4:0 D. Then if I said at some point that D equals 11010, then this tells me that D4 is 1 and D0 is 0. It's saying this is 4, 3, 2, 1, 0. But if I'm always dealing with them individually, if I'm never dealing with them in a group like this, then it doesn't matter if I do 0, 4, or 4, 0. It's just telling me which one, what order it's in. So that's what it's for. So, like, in the reason that it was important in the lab for me is for the display.
That's the issue I have in the lab.
Right,
All
is
I did was change the order.
right, and that's what it is.
It makes sense.
Yeah.
Can you scroll up a little bit? I just want to see the,
Other way. That
yeah, yeah, I think it's,
Can I take a picture of like the actual problem?
what was the actual
Like
problem?
you scroll up a little bit, like that.
oh, is it on the,
Yeah, this is from the exam review sheet.
is what you wrote below the question on it?
No. It will be, just the video will be.
Well, like that one, is that on it? With
Yeah.
that diagram? Alright.
This, well, not the purple. Yeah, that is all on it.
Okay. Can I take a picture of what's below?
Yes.
Thank you.
Mm-hmm.
Yeah.
About the Verilog. So, would the last N be in module or just in?
This would be it. Well, I didn't write the whole module,
Yeah, so.
so yeah. But the very last one would be an end module.
Okay, and in the wedge on the top, is that like, would that be the output or is
This is actually neither one, because really what I would do with this, well, I take it back. The way I have it written here, it would be output.
Okay.
Yep. Some of the code that we've done, we're using one always block to feed another always block, and when you do that, you can just make it reg because it's not the actual output.
City's not going to be a stickler for syntax.
No.